All right. Um, if you still haven't checked in to on campus, you need to do that. Um, Couple things today. So I want to continue to go over this right triangle trig stuff. I get that this is confusing. I know that like each individual piece is probably not as confusing as all of them put together. But having to remember SOHCAHTOA, having to remember the Pythagorean theorem, and then dealing with radicals on top of all that can be a little bit tricky. So we're gonna just continue to go over this. Um, Before we do that, today, so we're gonna go over homework and questions on that. I'm gonna start to do 11 to 19 odd step by step. So that is in topics. It is right triangle trig practice. That'll also kind of lead into your homework. Um, and then a couple of things before we actually get there as well. So homework. Um, and I'm not talking about this upcoming homework. I'm talking about the homework that you guys just did so that I excel. Uh, this class really only works if you guys actually do the homework. The more questions that I get, the more I can gauge where you guys are actually at, what you need help with, and what I can focus on. So if you straight up just did not do the homework, uh, you are not only not helping yourself, but you're also kind of not helping the class either. So do the homework. It's okay to struggle with it. I get that this is a different context, but we still need to be caught up and we still need to be doing this homework. All right. Um, I'll explain tonight's homework a little bit more in depth a little bit later on, but I wanted to just make that very clear. So if for whatever reason you did not do the homework, that is not okay. All right. You are still getting points for this. I'm still grading it. And it's also really helping us out with what to focus on. Okay. We can move a little bit slower here, and probably even a little bit more detailed and a little bit more efficiently too. So um, the more the more questions you ask, the better. All right, that's what's going to make this class work in this in this setting. All right. Okay. So today, I realize we did this last class as well. I want to go over a couple of these problems step by step in order to answer a couple of your questions. All right. So in that attendance kind of prompt, I asked, what are you struggling with? What don't you understand completely? And the question that I most got is dealing with the radicals and or something to do with radicals. Okay, so it might not just be simplifying the radicals. It might be dealing with them in the Pythagorean theorem or rationalizing fractions. Um, I'm not going to necessarily address each of those individually, but I am going to address entire problems as a whole so that you can see everything while still reviewing those little pieces. Okay. Um, and that's what we're here to do today. So my goal is to give you this kind of step by step thing to do that you just always do no matter what. That'll help you out just a little bit more. Um, and it's okay if you struggle a little bit. That's perfectly fine. This is new stuff. This is difficult stuff. And it's a little bit different too. So we've been working on proofs and postulates and just things that always work. This is more along the lines of back to math, okay, what you guys would call math, um, but it's in a different setting and it's dealing with some of that stuff that we did before. Okay, so if you haven't already tried this, I want to give you another like 30 seconds to at least look at the problem and be able to um, just kind of understand it and maybe start it on your own. But I would very much like you to have a notebook out, be writing this down, and physically go through with it. Physically go through this problem with me. Okay. Um, some of this homework can be really, really challenging. But I think a lot of the times when it is challenging, people are used to watching me do it and just follow along. That's okay. That's okay to start. But in order to get that next level of understanding, you have to kind of take a leap of faith and really do it for yourself. Okay, so take the next 30 seconds, really start this problem, and then we'll do it. I'll do it step by step so you can follow along. Okay, so 30 seconds, go ahead and get started. All right. So on the right hand of your screen, I have a more or less a complete like checklist of things to do for every one of these problems. Some steps you don't always have to do, but for the most part, this will get you through every single problem that there is. All right. And step one is to always define what sides you have. All right. That's one of the most important things that you can do right off the bat. All right. And those sides are determined by this right angle and by this angle theta. Sometimes these could be labeled, right? In which case, this is asking for the cosine of z. But for now, we're just going to focus on theta. All right. So in order to get the opposite side, we draw a line from our angle that we're worried about to the opposite side of the triangle. And that gives us our opposite side. In order to get our hypotenuse, the hypotenuse is always the biggest side, but sometimes you don't know one or two sides. So you start from the right angle, that little box. You draw a line from the box to the opposite side, and that gives us the hypotenuse. And then the side that's left, that's always the adjacent side. Okay, so that's step one. Again, just identify which sides you have and what sides you don't. All right. Next, we need to find the cosine, which is adjacent over hypotenuse. Okay, so we need the adjacent side and we need the hypotenuse. We do not have the adjacent side, so we need to find it. Okay, and in a right triangle, if you are given two sides, you can always find the third by using the Pythagorean theorem. So if we set that Pythagorean theorem up, it is always the adjacent side squared plus the opposite side squared is equal to the hypotenuse side squared. All right, and these parentheses are important, especially if you're going to be using a calculator for any of it. So I put those there for a reason, and I would like you to get in the habit of doing that as well. All right. So then we just substitute what sides we have in for their places. Okay, so we don't have the adjacent, so this stays the same. The opposite side is 3. And the hypotenuse is 3 rad 2. Okay, so we define what sides we have. We define what side we needed. And we set up an equation for it. Now we need to solve for that missing side. We need to solve for the adjacent side. So step one, or not step one, I won't say that. Now we just have to simplify and get the adjacent side by itself. Okay, so 3 squared, that's 9. We still don't know the adjacent squared. And then we can rewrite. So this, again, is probably where people start to get confused when there's radicals and squares, and they don't necessarily know what to do. All right, so this square, that just means we're multiplying whatever's inside by itself. So we can rewrite 3 rad 2 squared as 3 rad 2 times 3 rad 2. Okay, and again, it probably looks a little bit more intimidating than it actually is. Um, we need to simplify the right-hand side. We need to simplify this side in white. All right. So 3 rad 2 times 3 rad 2. That is really just 3 times 3, which is 9. And then a rad 2 times rad 2, which is rad 4. And then we can rewrite 9 rad 4. We can simplify that even a little bit further. 9 rad 4 is really just 9 times 2. So rad 4 just becomes 2. Okay, so I'm gonna stop there or pause there for just a second. Are there any questions with what I have up on the screen so far? How did you know you could simplify? I'm guessing you mean this part right here. So we can simplify that. That square root is asking what times itself is the inside. All right. So what times itself is 4? That's just 2. So the square root of 4 is 2. You could also plug the square root of 4 into a calculator or 9 rad 4 into a calculator, and it would still give you 18. Okay. But the square root symbol is always asking what times itself is on the inside. All right. So rad 4 again is really 4 is just 2 times 2. So square root of 4 is 2. So what if it was like a 64? Yeah, it would be 9. Well, hold on to that because I don't want to confuse people as we're going. All right. Um, we'll get to that. We'll get to something kind of like that in a minute. All right. So now what we need to do is we need to simplify and solve for that adjacent side. So we set up the equation. Now we need to solve the equation. Okay. So in order to solve, we just kind of just use regular algebra. We have to subtract 9 from both sides. And when we do that, we get that the adjacent side squared is equal to just 9. All right. Now, again, this is where a couple people will trip up just a little bit. We have to get the adjacent side, not the adjacent side squared. So we have to somehow undo this square symbol. In order to do that, we need to take the square root of both sides. All right. So like it's almost like the inverse of squared is square root. So you do those to each other in order to undo them. All right, so in order to undo the squared, you take a square root. And what you do to one side, you have to do to both. So what that does is it leaves just the adjacent side on the left. And then the square root of 9 is just 3. Okay. So again, I'll pause a second. Are there any questions over what I just did? And again, kind of going off of Alex's question, what times itself is 9? That's what this starred piece is asking. The thing times itself that's equal to 9 is just 3. So the square root of 9 is 3. Okay. So we solve for the missing side. We know what the adjacent side is. We know what the hypotenuse is. So then we can actually answer this question of cosine of theta. No, I would like that simplified. So can we keep it as the square root of 9? No, because the square root of 9 should be something that you know right off the bat. And if it isn't, it is now. Okay, so some perfect squares you guys need to know. 4, 9, 16, 25, right? All the way up to about 12 or 13. Again, what if it was like 22? We'll get to something that looks like that in a second. Right? But for now, let's just stay focused on this problem right here. Okay, so now that we have the adjacent side and the hypotenuse, we can substitute what we have and then simplify that. Okay, so we know that cosine of theta is adjacent over hypotenuse. Our adjacent side is 3. Our hypotenuse is 3 rad 2. And that looks like a good answer, at least right now. But that is not a rational fraction. Okay, that is not a rational fraction because there's a square root in the denominator, which we cannot have. Okay, so in order to rationalize this fraction, we have to get rid of this square root of 2. And in order to do that, we need to multiply by rad 2 in the numerator and rad 2 in the denominator. And we do that because really we're just multiplying by 1. So we're keeping everything the same. We're just changing how it looks. And what that does in the numerator, well, I'll start in the numerator first. So 3 times rad 2, that's just 3 rad 2. And in the denominator, we have 3 rad 2 times rad 2, which ends up being 3 rad 4, which simplifies in the denominator to just 2. And then if we keep going, we get 3 rad 2 over 6. And then we can simplify that by simplifying 3 over 6. So 3 over 6 is just 1/2. So we get 1 rad 2 over 2, which then is just rad 2 over 2. And then that rad 2 over 2 is our answer. Okay, so again, those steps on the right are kind of a good list of things to keep doing. All right, so you define what sides you have, you define what side you need, and then make an equation for it, which that's where the Pythagorean theorem comes in. You solve for that missing side. You substitute both sides that you need into your equation, and then rationalize and simplify. Now, this question seems like it takes a really long time. I'm showing you every single step, which is a very good exercise to do when you don't really know the material yet, which I would say you guys don't really do. Okay. As you continue to do this, as you get better at it, you start to recognize different things that you can take shortcuts with, right? So with this equation side, I would really probably only do that in about 2 or 3 steps as opposed to 6. Okay. This normally I just do in my head, and then this rationalizing part, the last part that we did, again, that's like a 2 or 3 step thing. Okay. So while this does seem like a lot, that's okay, and it probably is right now, but as we do this more and more, you'll get better and better at it. Okay. So again, let's pause for a second. Are there any questions about anything you see up on your screen? Okay. So again, these problems are all on campus. It's in topics. It's in right triangle trig, and then the one that we're using right now is right triangle trig harder, which will be your homework. Okay, so your homework right now for the next class is 10 to 20 on that worksheet, but just the evens. All right, and the way you're going to submit that is one of 2 ways. You can either download it as a PDF and then use your stylus and physically answer it on your laptop, save that, and then submit it to on campus. Or you can do it in your notebook, take a picture of it, and then submit that picture to on campus. Okay. This worksheet is in, again, this worksheet is in on campus. It's in topics. It's in that right triangle trig topic, and then this is right triangle trig harder. Okay. It is also attached to the actual assignment in on campus. Okay, which should be showing up right now. Right. But we're going to continue to go over some of these examples because I realized this didn't necessarily answer every single question that you had. Okay, so while you do have the homework, we're still going to go over examples on this. Okay, but we're going to be working from that worksheet. You can do it in OneNote, but I would like you to submit it to on campus, which means you need to save it in a PDF form. I get that that's one extra step, but I want it all in one place. Okay, so your homework is 10 to 20 even. We're doing 11 to 19 odd. All right. So that was number 11. And then number 13 looks like this. All right. So I'll give you a kind of a minute, a couple seconds to write it down. And as you're doing that, keep in mind that we have like these 6-ish steps to do each one of these problems. Okay. And step 1 is always to determine what sides you actually have. So given this angle theta, we can get the opposite side. So if we draw an angle from theta, sorry, a line from theta to the other end of the triangle, we get our opposite side. From the right angle, okay, if you don't have a stylus, then you can do it in your notebook and then take a picture of it. From your right angle, if you draw a line from your right angle, that side is your hypotenuse. Okay, I'm going to say this one more time. It is one. The worksheet that is for homework is attached to your assignment and on campus. It is also in topics. It's in the newest topic, and then it's right triangle trig harder. Okay. Can I print it out, then take a picture and email it to you? I do not want emails for this homework assignment. You guys are supposed to be able to submit it to on campus. There is a submission place to it for it in on campus. I want it there. Okay, that helps me immensely when I'm grading stuff like this. Okay, so I do not want emails here. I want submissions to on campus. Okay. So we have the opposite side, we have the hypotenuse side, which means that this other thing is the adjacent side. Okay, so we define what sides we have, and then we need to define what side we need. Okay, so sine, given SOHCAHTOA, sine is opposite over hypotenuse. So we need the opposite side, and we need the hypotenuse. So we have the opposite side, we do not have the hypotenuse, so we need to find it by using the Pythagorean theorem. And what that says, again, is that the adjacent side squared plus the opposite side squared is equal to the hypotenuse side squared. And then we can replace these adjacents and opposites with what they actually are. So the adjacent side is 24. The opposite side is 7. And then we still don't know the hypotenuse. (24 squared), if you plug that into your calculator, or 24 times 24, that's 576. 7 squared is 49. And then we still don't know the hypotenuse. Okay, so we define what side we need the hypotenuse, and we wrote an equation for it. Now we just need to solve that equation. Okay, so 576 plus 49, that's 625. And then we need to solve that. Okay, but before we do that, I'm going to pause here. Are there any questions about anything you see up on your screen? Okay, so now we need to solve for the hypotenuse. So in order to do that, we need to cancel out this squared. In order to cancel out a squared, we have to take the square root of both sides. And when we do that, we're just left with the hypotenuse on the right and the square root of 625 on the left. And now we need to simplify that square root of 625. Okay, and again, this is where people will get tripped up a little bit. Now, what I like to do is make a factor tree, which, again, as you get better at this, you won't need to do as much. Okay, but it's always helpful. And there are a couple of things that we can keep in mind. All right, so any number that ends in 5 or 0, that's going to be divisible by 5. Any number that ends in a 2, 4, 6, 8, or 0, that number will be divisible by 2. And then any number whose digits, when they add up, they're divisible by 3, that entire number is also divisible by 3. Okay, and we'll go over those kind of as we go. But those are 3 kind of simple tricks that you can use in order to factor these things better. Now, you can also just take the square root of 625 on your calculator and you'll get an answer. Okay, but I want to do this very quickly just to show you kind of what's going on. Now I notice that these last 2 digits, because that's 25, I know that 25 goes into everything. Okay, so 25 is definitely a factor of 625 because the last 2 digits are 25. And then if we divide 625 by 25, we get 25 as well. All right. So 625 is a perfect square. It's 25 times 25. So then our hypotenuse, if we simplify this radical, it's just 25. Or you could say it's square root of 25 times square root of 25, which is kind of where I was leading you with this. Square root of 25 is just 5, 5 again. Those 2 times each other. Again, that's just 25. Okay, there are several different ways to do it. And again, as you do this, as you get comfortable with it, you'll be able to do 1 or 2 or 3 of these ways very, very quickly, and it just won't take any time. It's also helpful to know certain perfect squares. Again, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and then it keeps going. But knowing those certain numbers is very, very helpful, which again you will do with practice. Okay, but now that we have the hypotenuse and the opposite, now we can substitute what we have. So the opposite side is 7, and we just found our hypotenuse, which is 25. Okay, and then we should rationalize it, but that's already a rational answer. And then we can simplify it, but there are no common factors of 7 and 25. So this is your answer. All right, so again, we'll pause for a second. Are there any questions over any of this that you see on your screen? Okay, so we'll do 1 or 2 more examples. and then I'll give you guys, and then I'll be on Teams to answer any questions you have, like, specifically. All right. So number 15 on that same worksheet gives you this diagram. So that's number 15. And we're trying to find sine of x. Okay. So the angle we're dealing with is x, which is this angle right here, right? It has to do with this vertex. So we're dealing with this angle. Okay. If we draw a line from this angle to the opposite side of the triangle, we get our opposite side. If we draw a line from our right angle to the other side of the triangle, we get our hypotenuse. And then the other side is the adjacent. So that's step one, just defining what sides you have. Then we need to define what sides we need, and if we need to, get an equation for it. Okay, so sine, given SOHCAHTOA, is always opposite over hypotenuse. Okay, and we actually have both of those sides, so all we need to do, we don't need to solve for any missing side. All we need to do is substitute. So the opposite side, that's 5. Our hypotenuse is 13. And then if we need to, we would rationalize here and then simplify. But this is a rational fraction, and it's as simple as it can get. So then this, 5/13, is our answer. So questions about this problem? Do we need to find the other side? You could, but you don't need to, because for sine, we only need the opposite side and the hypotenuse. So we could find the adjacent side, but it doesn't really do anything for us. Now, if it said cosine of x, we would need the adjacent and the hypotenuse, so we would have to solve for the adjacent side. So some of these problems are way simpler than what they look like. Okay. So we'll do one more example. And this is taken directly from IXL, but we'll do this example. There's like a quick, maybe small thing that I'll go over during this example, which should cover it. But if it doesn't, I'll take more questions about it. And then after that, I'll be on Teams and I'll answer more specific questions. Okay, reminder, your homework is 10 to 20 on this same worksheet. And then you submit that 10 to 20 evens, and then you submit that to on campus. All right. So this question taken directly from IXL, this is in like the 90s part, is asking you for tangent of K. All right. So again, step one is to define what terms you actually have. So let's start at the angle K. And let's draw a line from K to the opposite side of the triangle. And that gives us the opposite. And I'll give you a second to kind of write this down. I realized I didn't do that. So take a second, write it down, and then we'll keep going. Okay. So then we can find the hypotenuse by starting from our right angle, drawing a line to the other side, and that gives us our hypotenuse. And then the other side, the only side left, that's our adjacent side. Okay, so again, step one, just determine what sides you have. Then we need to define what terms we need, and then if we need to, write an equation for it. Okay, so from SOHCAHTOA, tangent is opposite over adjacent. And we have both of those sides. Okay, so the opposite side, that's square root of 57. And then our adjacent side is square root of 11. Now this should cover kind of like the rest of the questions. All right, you have a square root in the denominator and numerator, but we still need to rationalize it. Okay, and you still do the same thing. You still take the square root in the denominator, you multiply it in the numerator and denominator, and then we start to simplify it. Okay, so square root of 57 times square root of 11, that's 627. And then the square root of 11 times itself, that's just 11. Okay, so whenever a square root kind of multiplies by itself, that square root just cancels and you're left with that whatever's inside. All right, so like the square root of 8 times the square root of 8, that's just equal to 8. And that goes for everything. So square root of 41 times square root of 41, that's just 41. Okay, but now there's a question of simplifying that numerator. So let's take the numerator and try and make a factor tree out of it. Okay, and again, there are different tricks we can use. Okay, this last digit, that's not a 5 or a 0, or an even number for that matter. So it's not divisible by 2, and it's not divisible by 5. But if you add up each of these digits, 6 plus 2 plus 7, that's equal to 15. And 15 is divisible by 3, which means 627 is also divisible by 3. So if we do 627 divided by 3, we get 209. And then, well, neither of these two numbers are perfect squares. So that's not necessarily our answer, but we can further do different factors, right? So what Alex just said, 11 and 57 is another one that can be done, which really should be our first option because they show up there. Okay. But as you factor it, none of the factors end up being perfect squares. Okay? Which is really the only thing that allows us to simplify these square roots. All right, so our only goal in doing this factor tree is to pull out perfect square roots. So really, this question is done right here because we can't pull out any perfect squares out of 627. Okay, so that question is done. That's what determines when you stop. It's when you can't pull out perfect squares of the thing underneath the square root. Okay, but I want to do kind of well, I'll stop there for a second. Are there any questions about what I just did? Okay, and I want to show you one more thing, and this is something that will end up showing up on your homework if you do it right. You end up getting something that looks like the square root of 392, and I think this ends up being your hypotenuse. So you stop no matter what if there isn't a perfect square. If there isn't a perfect square factor that you can pull out, yes, that's when you just stop. You can't simplify any further. Why don't you simplify 627? You can't simplify the square root of 627 because there are no perfect squares that you can take out. All right, and again, a perfect square is something like 4, something like 9, something like 16. There's no perfect square that you can take out of 627 in order to simplify that radical. Okay, now, again, this square root of 392, this will show up in your homework and ends up being the side of a hypotenuse. All right, and we can simplify this, and I'm going to do it slightly different here. By just factoring out 2's. And this is one kind of strategy that I use. All right, so when the last number is a 2, a 4, a 6, an 8, or a 0, you can always factor out a 2. Or you could skip ahead and do 49 and 8. All right, but if we do this, so if you're ever stuck, we start to just keep factoring out 2's. Okay, and we end up getting this factor tree, all right? So what that means is that we can multiply all of these numbers together and get 392. So we can rewrite the square root of 392 as the square root of each of the circled numbers. And this way always works. Okay. It's kind of like a fail-safe, but it's kind of brute force. Sometimes it takes a little bit longer than others, but usually it always works. All right. And then we can simplify all of this by canceling out doubles. And what I mean by that is every time you see something repeat itself, we can just leave what's inside the radical. So square root of 2 times square root of 2, that just becomes 2. Square root of 7 times square root of 7, that just becomes 7. And then we're left with this square root of 2. And then we can multiply 2 and 7, that's 14. Square root of 2 stays there, and we're left with 14 rad 2. So if you did it Thomas-Ellis way, which is 49 and 8, you would rewrite it as the square root of 49 times the square root of 8. That square root of 49 is 7. We can rewrite 8 is 4 times 2. Which ends up being the same thing. Okay, but if you want to keep it really, really simple, you just keep factoring out 2's. In some cases, you factor out 3's. In some cases, you factor out 5's. It just kind of depends on the number, right? Are there any questions over this? Okay, this is kind of a little bit more in depth on simplifying radicals. Okay, so questions about this so far? Okay, so since there are no other questions about this, um, I'll move over to Teams. I'll start a meeting, and if you have any really specific questions, you can ask me there. All right. Now, keep in mind before you actually leave, this lecture is up here forever now. So if you ever need help with any of this stuff, you can always go back to this lecture, and then obviously you can always come to me. Okay. Um, so I'll leave this open for the next 30 minutes, if, or sorry, 30 seconds. If there's any general questions, I'll answer them quickly. And then in the next 2 or 3 minutes, I'll be on Teams and we can talk more if we need to. Okay. So if there aren't any questions, I'll see you in a couple minutes. If there are, hang around for 5 or so seconds and I'll try and answer them. Yeah, so 10 to 20 evens on your homework. Um, if you take a picture of it, only submit the JPEG. Don't put it into a Word doc because it's a lot harder to read when you put it in a Word doc. So actually submit the actual JPEG. Okay. So I'm going to close this and I'll be over on Teams. If you have further questions, we can work on there. Yes, you can just submit a picture of your work. All right. So I'll see you in a couple minutes and I'll be there.